Okay, so we're going to start section 8.7, but before we do that, we decided to kind of recap some vocabulary. All right, so the first question, this is more just to kind of have you think about, says, what is a rigid transformation? So this is kind of going back to like a month ago. Okay, so can you remind me, Ms. Gravy, what a rigid transformation is?
Okay, well, we talked about like transformations, so like rotations or reflections or translations. They were all rigid transformations where they were isometries.
Okay.
So everything that we knew about one figure, like all the angle measures, all the segment lengths, are the same in this new figure, in the image. And we said basically the pre-image and the image were congruent.
Okay. So they're isometries, which basically meant the image or pre-image is congruent to the image. Now, she gave some great examples of rigid transformations, the reflections, rotations, translations, but those are just special kinds of transformations out there.
Those are all the rigid transformations.
Not all transformations are considered rigid. Okay, that's all we really focused on chapter 7. We are going to talk about something that is a non-rigid transformation. So what do you think?
Well, if to be rigid means that they're going to be congruent. So maybe non-rigid, since we're in our chapter on similarity, would be that those figures are similar.
So not congruent, but similar in a sense. So this would mean the pre-image and your image are similar after you perform whatever transformation you're going to have. Okay? So what we're going to do is this section is all about a special type of non-rigid transformation. Okay?
Okay. So we're going to be focusing on dilations. And dilations are non-rigid transformations where your pre-image and image are similar. And that's going to be the idea. And when you think of a dilation, what do you think of?
I think of like your eyes.
Yeah, that's
like
frequent.
If you've ever gone to the doctor, eye doctor, which I actually have not, but I know they dilate your eyes. And what does that happen? What happens when they do that?
Your pupils get huge.
Yeah,
all of a sudden, and everything, you're really sensitive to light. But yeah, the whole idea is your pupils are dilated. They're similar, but all circles are similar. I guess that's kind of a weird one. But you know, but that idea of they are larger than what they appeared.
A lot of times, to me, a dilation is kind of like a size transformation in a sense.
I love that vocabulary, that idea there.
So the size is changing. So all the corresponding angles will be congruent, but the corresponding sides will be proportional.
I think that's important because we know that is true about all similar figures too. The corresponding angles will be congruent, but the corresponding sides are proportional. And so that's going to be the big things that you're going to see here. Now, keep in mind, dilations does not always mean that it's going to get bigger.
No.
Could get bigger, but it could also get smaller.
All right, so we're going to learn some vocabulary. The slide kind of has a lot going on in it. There's some things that you're going to have to really pay close attention to. All right, so let's go through it. All right, so we already know what a dilation is. Kind of mathy-like. It says a transformation that maps every point P in the plane to a point P prime. Okay, so it's going from one point to the next. So the following properties are true. All right, so these properties are what we got to remember. All right, so let's say that point is not the center point C. So with a dilation, you have to have a center of dilation. All right, so if you're dilating a point that's not actually at the center, they're saying that that image point, P prime, lies on ray CP. Now, what's point C again?
The center.
And point P is the
actual pre-image that you start with.
Pre-image. Okay, so P is, again, that's your pre-image. And your P prime is your image. Remember that, okay? That
just like what we saw before.
So your image is going to lie on the ray that connects basically the center to the pre-image, all right? Scale factor. Now, we've learned about this word this chapter, all right? What's the scale factor again?
It's when I'm comparing two sides of two figures, the corresponding sides. It's that ratio that compares those corresponding sides.
Scale factor only involves similarity, so that's why it's going to kind of be here. So the scale factor is basically the ratio of corresponding sides. That's what we remember from earlier in this chapter.
Right.
Now, another way of thinking of this with a dilation is that the scale factor is always a positive number such that, and we're going to use the variable k for our scale factor. They like to use that variable k. It equals the distance from the center to the image, notice P prime, so C to P prime, that distance, over the distance from the center to the pre-image. Okay? So, just something to keep in mind there. Now,
and that's
notice
something that people struggle with because we usually think pre-image over image, but when you're doing scale factor, it's got to be the image over pre-image.
I'm going to even make a note of that.
That's a very common thing that people will forget.
So you can think of scale factor as the ratio of corresponding sides. That's if they give you the corresponding sides of your pre-image and image. But sometimes they don't. And if they give you the distance from the center to the image, you're going to compare that to the center to the pre-image's distance. Okay? Now notice they say k cannot equal 1. If the k, which is your scale factor, did equal 1, that would be the ratio of corresponding sides is 1. What would that mean?
Well, that would mean like for every 1 unit on one figure to have 1 unit. That would mean that they would be congruent, not similar. So it wouldn't truly be a dilation.
It wouldn't be a dilation. So with a dilation, something size-wise is going to change. Okay? They will not be congruent. Stressing that. Now, the property 2, it says if P is the center point C, then P is the same thing as P prime. It's kind of like when we talked about transformations last chapter.
Like when you reflected across a line?
If it was on that line, it stayed on that line. So I would say this is something as property 2 is, I think, more logical. Property 1's the big one, okay? Yes. Kind of throws in that scale factor idea. So I might even star that to remind you there, okay? So some good stuff. Hopefully you're writing that down. Okay, just a key down here. Again, K is a scale factor, C is your center point, P is your pre-image, P prime is your image.
And they won't always be P's and P primes, but you guys know that when you've got a variable and it's the same variable that's prime, same letter that's prime, not really variable, but same point that's primed, you know that's going to be your image.
Good. All right, so some other things down here are important. It says the dilation is a reduction if 0 less than k is less than 1. So they're saying, what's k again?
The scale factor.
If k is somewhere between 0 and 1.
So if it's a fraction.
Okay, well, not necessarily fraction.
Okay, yeah.
4/3 is a fraction.
Yes, that's true.
So something less than 1, but greater than 0. Again, it has to be positive, so that's why you have that restriction here. It's going to be a reduction. Okay, so like a half would be a reduction. Okay? A dilation could be also an enlargement if the scale factor is greater than 1. Notice neither one is equal to 1. So it's either between 1 and 0 or greater than 1. And hopefully this makes sense. Reduction, what's going to happen?
It's getting smaller.
Yeah, it's going to get smaller. And enlargement?
It's going to get larger.
Yeah, or bigger, larger. Okay? Common sense. All right? This is something that is a no-brainer but can be easily mistaken if you're not careful. All right? And again, this is talking about going from how is the shape changing from pre-image to image? All right?
Okay. All right. Identify the dilation and find its scale factor. So first of all, just by looking at this, what can you tell? What's the figure that I started with?
Well, the pre-image is the one without the prime symbols. Also, we have it in blue.
Exactly.
So that triangle right there.
So there's our pre-image, and we know then obviously the image is the one that's going to be in red. Okay, because it's got the prime symbol, so that's where we're going. Now, just by looking at it, I'm not even going to do any work yet. Does it look like my image is getting smaller or larger?
It's getting smaller, so it'd be a reduction.
This is a reduction.
Now, I like that you said that because now that I know it's a reduction, I know the scale factor is going to be somewhere between 0 and 1.
Exactly.
Okay.
Okay, now, they do ask us to find its scale factor. Now, the first thing I want to point out, do we have any side lengths on either one of those triangles to compare the corresponding sides?
No.
Okay. If we do, that'll be the first thing we'll do is we'll write that ratio of corresponding sides just like we're used to doing.
Okay.
All right, but when we don't have that, now we have to go back and think about what that little property that we wrote down, that first property that said that if P is not the center, which there's no point here that is marked on my center point.
Okay.
Okay. And by the way, these lines that you see coming from that center are just showing you that that image is on the ray that would contain the center point and that pre-image.
Okay.
Okay. So none of those points are on the center. Then it says the image point P prime. Oh, sorry. We just talked about that. Then the scale factor, there we go, is a positive number such that from the center to our image over the center to our pre-image will be how we can represent our scale factor. So let's take a look. Do we have measures that go from the center to our image?
Yes. So the distance from C to P prime in this case is 3.
Okay. So this is helping us to find that scale factor. All right. And then what about from the center to my pre-image? Do we have that measure?
That would be, a total distance would be 8.
Good. All right. So my scale factor here is
3/8, and that's simplified. So now, common mistake that I often see when people put 3/5, and that would be between 0 and 1. But the 5 is actually the distance between the pre-image and the image, which nowhere are you going to use that distance.
Right. So just things to keep it, and that is a very common mistake that people will make. So notice that, first of all, we're going to the image first. The image measure is always going to be the one on top. And then from the center to the pre-image for the one on the bottom. Now, some checks for yourself. All right, we first just looked at the picture and said, we know this is a reduction. As it's getting closer to the center, you're going to notice that it's getting smaller. So this is a reduction. We knew that right away. Once you find your scale factor and you see that ratio of 3/8, make sure that that shows that it is a reduction, that it's less than a whole. If you wrote 8/3, chances are you did the pre-image on top and then the image, but you would hopefully then realize that would be an enlargement because it's greater than 1 whole. Okay.
All right, I think we have another one like that.
We
So
do.
I'm going to encourage you guys to do this one on your own. Same directions. Identify the type. So is it a reduction or an enlargement? And then find the scale factor. So do that and then check with us. Okay, so which one is the pre-image?
The pre-image is the one without any of the primes. The
Okay,
blue up
so
here.
this one right here is your pre-image right here. That's your pre-image.
Exactly.
And then the image is, of course, the other figure with the prime symbols.
Exactly.
All right, so first of all, what type do you think this is?
This is an enlargement. So I can definitely tell that it's getting further from the center. It's getting larger.
Good.
We
And
see
I like
this.
that you said that. Further from the center, so it's getting larger from that. All right. To find the scale factor, which is the next thing, first thing we check to see if we have any corresponding sides that are given, and
No corresponding sides given on this one.
so that means we have to find it by finding the distance from the center to the
Pre-image first, so the Q prime. And
to the image, not pre-image.
Sorry,
You said
I said
Q
Q
prime.
prime, but yeah, to the image first, which is the Q prime. And guys, as I'm looking at that too, notice that this one, that's the longer distance. Before it was the shorter distance, so it's not always the shorter one on top.
And
And
notice
then-
it's not to P prime type thing. That's okay. They're still giving you distances from the center to the image.
To a point and its image.
It doesn't matter. It does not matter if it's P prime. It could be S prime, whatever. All right, so from the distance from the center to its image point. So
Okay.
what's the distance from here to here?
So that's going to be a 9.
And the distance from the center to its pre-image is,
2.
and make sure it's simplified.
9/2 is
which
simplified.
it is. So there's your scale factor.
And it's larger than a whole. So it is an enlargement. Awesome. Okay, now this one says we're going to identify the dilation and find its scale factor and find some values of the variables. All right, so first of all, as you look at this figure, where do you notice the center of dilation is?
The center dilation is basically inside both of the pre-image and the image.
Right. So you're going to notice that these pieces are really going to be totally overlapped when you look at that center being inside of the figures. Just something to be aware of. That's okay. You can have a center outside the figures, inside the figures. That center point won't matter.
You'll notice, though, that like going back to that property, that distance from the C to the image is still on that ray, technically, that goes to the pre-image. So it's still on that ray or segment or whatever it is.
Now, which figure is my pre-image here?
The pre-image is the figure ABDE, doesn't have the prime symbols. So
Exactly, the blue.
blue one.
Okay, and then which one is the pre-image?
The pre-image is the
Or sorry, the image. Did I say pre-image again? Sorry.
That's okay. Image is the one with the prime symbol, so the one in red.
Okay. So when you're looking at these, would you first of all say, when we identify what type of dilation?
So it'd be a reduction.
Exactly. It's getting closer to the center. And it's getting smaller. And so as we're trying to find that scale factor, so we've identified it, we're going to find its scale factor. Notice here we don't have any of the points to get from like the center to any of those pre-image and images. But here we do have some corresponding sides.
Which, that's something we've already done before.
We've done this before.
Okay.
So this part of finding scale factor will be a little bit more normal.
Now, going back to when we talked about scale factor, it was the ratio of the corresponding sides. And usually they told you, okay, compare this to that. Since they're not really saying that in the sentence, but we do have to be careful, right?
Oh, yes.
What do I always put on top?
Just like when we go from C to C prime first, you'll always start off with the image over pre-image.
Okay.
Always.
So if I was looking at that, in the image, the prime one, I see sides of 9 and 15. Now, 9's not going to really help us because A prime, B prime corresponds to AB and it's unknown. So I would probably do like, let's say A prime, E prime, and compare that to AE.
Okay.
And so it would be 15 to 20.
Awesome. And that does simplify.
So that simplifies to 3/4.
So there is our scale factor.
And that makes sense because reduction should be between 0 and 1.
Okay. So we've done two parts here. We've identified it. We found its scale factor. Now they ask us to find the values of the variables. And this is going to be based off of the same ideas that we've done with similarity before.
Yeah.
Once you know a scale factor or a ratio of the side lengths, can I then find the other corresponding sides that are not given?
Yeah, because these are similar.
Okay, so give me the proportion that you're thinking.
Well, I'm just thinking one that's pretty easy. Y.
Uh-huh.
I can just say Y is 20.
And why do you know Y is 20?
Because these are similar rectangles in a sense, or, well, we know they're parallelograms. We can't really say for sure they're rectangles, but opposite sides are congruent. So
right, and we know that from the image figure.
Image
so
figure.
If they're similar, we definitely know that's true of the pre-image.
Okay, so let's say I'm finding X now.
Okay.
All right, so if I'm kind of sticking with this idea of maybe using my scale factor, and I have my image to pre-image, so let's say 3 to 4, then I would compare that, so set that equal to 9 over X.
Right. Now, you could have used 15 over 20 if you wanted to, but we might as well go with the simplified ratio. So then we know our 3x is going to equal
36.
It doesn't freeze on me. 36, and when I divide by 3,
X is 12.
X is 12. So that tells us that this side length is 12. The other side we are supposed to find a z.
Which is going to also be 12.
Exactly.
So really, we only really had to use the scale factor instead of proportion for one of them.
Right.
Okay, so the other thing about dilations, which, you know, kind of makes sense, because if we think back to Chapter 7, we did a lot with the coordinate plane, and it was dealing with transformations. This is just a non-rigid transformation. We are going to apply dilations to a coordinate plane now. It says, in a coordinate plane, dilations whose centers are the origin. Now, I'm going to stress that if the center changes and it's not the origin, this property is different. Okay. But for our purposes, we're only going to focus on the center being the origin.
Yeah.
Okay.
And that's very common that you would see.
It says we'll have this property where the image of P. Okay. So this is your pre-image. All right. Notice it doesn't have a prime symbol. So they're just giving you some coordinates, x, y. Now this is your image, what they're talking about.
So
the image
of P
of
is P
this is this. So notice what you did. Notice the pre-image is your x, y. To get the pre-image, or to go from the pre-image to the image, what did I basically do to the pre-image?
Multiplied both the x and the y value by the scale factor.
And the scale factor, of course, is what we use as k. All right, so to get from here to here, you're just multiplying the pre-image, both coordinates, by the scale factor.
All right.
Okay, so just kind of maybe make a note of that. So multiply the pre-image coordinates, x and y, both of them,
by the
scale factor. All right, so let's actually do that. I'm going to have Miss Hochgraby show us how.
Let's talk about it. First of all, it says, draw a dilation of triangle ABC. And we've got the points for our triangle. And I went ahead and drew that on my paper already. And it says we're going to use the origin as the center. And we're going to have a scale factor of 3/2. Okay? Now, we could go ahead and we can try to maybe draw that, but it's not necessarily very easy to just draw it first without finding the points. So let's go ahead and let's find what the points will be for A prime, B prime, and C prime. Okay. So that means to get to A prime, what am I going to have to do?
I'm going to have to multiply the coordinates of A by 3/2.
Exactly.
So I'm going to multiply -2 times 3/2 and 1 times 3/2. So the first one would get you -3, and then 3/2 or 1 1/2, however you want to write it.
I'm going to write 1 1/2 because to me it's easier to plot that point. Okay, so then what about to get to B prime?
Do the same thing to B, multiply the -6 times 3/2 and 0 times 3/2. So it'd be -9, 0.
Okay.
And then C prime, to get that, you're just going to multiply -1 times 3/2 and -1 times 3/2.
Do it twice.
So it would be a -1 1/2 for each of them.
You could do -1.5, -1 and 1/2. You could leave it as -3/2. I just want you guys to realize that there's lots of ways to write those. Okay, now that I've got these 3 points, I'm going to be able to now
graph it.
Okay, so to get to point A prime, I'm going to go back 3, 1, 2, 3, and up 1 1/2. So there's going to be my A prime.
Now, while she's graphing these, guys, one thing to keep in mind is that, just like last chapter, give the coordinates. Just because it says draw the dilation, we still want to see the coordinates. So make sure if they do ask you to graph, also write the coordinates off to the side, okay? And label your picture correctly. Notice how she's labeling this second figure she's drawing in with the prime symbols.
One thing I want you guys to notice, what should have happened if my scale factor was 3/2?
It should have gotten a bigger picture.
And did we get a bigger picture? Okay, and what else should kind of be true about these figures?
They should be similar.
They should be similar.
So we could technically check that idea.
You could do a little distance formula work here. Okay, and what also should kind of be true about like the sides of those two, of the pre-image and the image? If they're starting from that same point, what's something that maybe you're noticing about those sides?
Like what? I mean,
well, like if I look at AB and A prime B prime, they look like they're maybe what?
Proportional.
Proportional.
Well, because they're similar.
Right.
I'm sorry.
Okay.
I was like, I thought we already established that.
No, they're proportional. So if I look at those sides, the change that's happening in that the amount of change that's happening between A, B, and A prime, B prime should be about the same amount of change that's happening with each of those sides. So just kind of some things when you're looking at it, you shouldn't end up with an all cattywampus figure. It should look similar to and have those sides be kind of in that same proportion as what your original figure was.
Interesting word you use there.
Sorry, cattywampus? You didn't let that.
No, I just said it's an interesting word.
Okay.
The other thing I want to comment on is notice if you connect from the center, which is the origin, and kind of connect that along there, the pre-image and image should lie on that same ray.
Oh gosh, I should just use my little line tool. What am I doing? Yes, they should.
You see what she's doing there? Notice that. They should lie on the same exact line or ray or segment, whatever.
Love it.
Okay.
Next question says, how does the perimeter of the pre-image compare to the perimeter of the image?
Well, this is kind of going back to if they are similar, which we know they are, I know that if I compare the perimeter ratio of similar figures, it's going to be the same thing as a scale factor. Now, based on what they said, how does the perimeter of the pre-image compare to the perimeter of the image? It would be actually not 3/2, it would be 2/3.
Right.
Kind of flip-flop.
Because we know that scale factor goes image over pre-image.
And since they're saying basically compare the pre-image to the image, you're just doing the reciprocal of that. So then the ratio of that would be 2/3.
Exactly. So just watch the order because the order does matter when they specify an order, but also look for it's going to be the same idea as the scale factor. It's just watch the order.
And notice here, we didn't even have to actually find the perimeter.
No,
which
if
means
we'd asked
we
you
didn't
to
have
do that.
find the distance formula. Guys, that ratio of the perimeters is really important concepts that we want you to remember, okay? All right. We have one more example. This one's already drawn for you, and they're going to ask you to decide what kind of dilation it is. So we've done this already. So reduction versus enlargement, and then finding the scale factor. So it's a kind of a question we've answered before. Now we're applying it to coordinate plane. Okay. All right. So first, tell me, which dilation do you think it is? A reduction or enlargement?
This is a reduction, because as I look at the original pre-image that goes with the blue rectangle up here, that has no prime symbols, is definitely getting smaller as it's getting closer to that center of the origin.
Okay, and again, the center, like we said earlier, is going to be the origin on all of these that we do. Yeah. Okay. It says, what is the scale factor of this figure or this dilation?
Now, we could find from like 0, 0 to get to point maybe t prime, and then to get to t, that would require some distance formula. So that is one strategy you could use.
Okay.
I'm doubting a lot of people are going to say, hey, I would love to use the distance formula. Let me do that. Because if this is a rectangle, we also know we can look at the corresponding sides. And the way that these rectangles are drawn, they're drawn really nicely to where I can actually just count those horizontal or vertical spaces. And I'm going to count horizontal because I noticed they're whole on both of those.
Okay. So which segment are you finding the distance of first? Now remember, scale factor, what are we going to put on top?
The image over pre-image.
So I'm going to make a little note of reminder that. Notice we keep saying that. Probably something we want to remember. Okay. So which image segment are you going to find?
Let's do TR and compare T prime, R prime, and then TR. So from T prime to R prime, that's 3 spaces when we count. And from T to R, that's going to be 6.
Simplifies down to
1/2.
So there's your scale factor. And we said it was a reduction, which is less than 1. So that would make sense. Now, another approach you could do is you could find maybe the coordinates of, you know, the image and the pre-image, and then just see how do they compare. All right. That's really nice if it's not segments that are horizontal or vertical.
Right.
So what I mean by that is, like, for example, T. What are the coordinates of T? 4, 9.
Yeah, 4, 9.
Okay. And then T prime, we know it's 2, and it looks like it should be 4.5, but just looking at it, okay, what's basically from the
so it's
image to pre-image, 2 to 4, that's 1/2 as well. Right? Why would that be nice is if I give you a figure that is like
not something easy to just count.
Okay? So instead of having to use a distance formula, basically.
Right.
Okay? So
giving you other strategies.
Yeah, so different ideas. It's just kind of up to you.